Hello everyone, good evening. So in this lecture I am going to explain about forward bias and reverse bias of diode. Like forward bias क्या होता है, reverse bias क्या होता है, and we'll discuss about the VI characteristics of diode during forward bias and reverse bias. So without wasting time, we'll start this session. My name is SRP. You are watching my beautiful channel, Love You Science. So let's start. Biasing of PN junction. Biasing of PN junction, or you can say diode. Biasing of diode. So there are two type of biasing. One is forward biasing, second is reverse biasing. In case of forward biasing, the P layer of the PN junction is connected to positive terminal of the battery and N layer is connected to negative terminal of the battery. But in case of reverse bias, the situation will be reverse, like positive terminal of the battery is connected to N terminal of the diode and negative terminal of the battery is connected to P layer of the diode. So as I've told, biasing are two types. So one is forward biasing, second is reverse biasing. So in case of forward biasing, the P है ये N है, ठीक है. तो positive terminal of the battery is connected to P and negative terminal of the battery is connected to N. But in case of reverse bias, so this one is P and N. So negative supply of the battery is connected to P and positive is connected to N. Again I repeat, plus is connected to P, minus is connected to N, that is forward bias. If minus is connected to P and plus is connected to N, that is reverse bias. ये तुम्हारा external power supply, ठीक है. Then what will happen in forward bias and reverse bias? Let us discuss. So as I have told already, we during the formation of PN junction we have some positive immobile charge ion and negative immobile charge ion across the junction. So the potential across the junction is called potential barrier, that is VB. ठीक है. देखो what will happen when positive terminal of the battery is connected to P and negative is connected to N. That external voltage will develop a electric field and that will act against that electric field due to this potential barrier. Again I repeat, that is supply voltage develop a electric field. That electric field will act against to that electric field due to the potential barrier. Are you getting my point? Are you getting my point? When positive terminal is connected to P and minus is connected to N, that potential difference will develop a electric field, strong electric field, which will act against that electric field due to this potential barrier. First point clear. Second point, since the value of potential barrier is very small, so very small amount of energy is required to eliminate that junction, or very small amount of potential difference is required to eliminate that junction or layer. Is it clear? So that voltage is called knee voltage. Which voltage? Knee voltage. So it is the threshold voltage or minimum voltage which is required to break that junction. So once that junction will break, what about the internal resistance of that junction? The resistance becomes zero. Then it can easily conduct current. Is it clear? Again I repeat the operation of forward bias. Whenever potential difference is applied across P in junction and plus is connected to P and minus is connected to N, so that potential difference will develop an electric field. That electric field will act against the electric field developed due to the potential barrier. Since potential barrier is very small amount of energy or small amount of voltage is required to eliminate that junction. So once the junction will be eliminated, the resistance becomes zero across the junction and it can conduct current. So that means current can easily flow from P to N. Is it clear? But during reverse bias, situation is different. So during the formation of PN junction, as I've told, यहाँ पे क्या था, positive charge accumulation था, positive and negative charge accumulate near the junction. Whenever a potential difference is applied across the PN junction and minus is connected to P, plus is connected to N, what will happen, that potential difference will develop a electric field. That electric field will act on the same direction of the electric field due to the potential barrier. ये potential barrier कितना है, VB. So what is the direction of electric field due to the potential barrier? From N to P, right? So here the potential external potential difference will develop a electric field. That electric field will act along the same direction of that electric field due to the potential difference. मतलब that electric field will support it. मतलब it act in the same direction of electric field due to VB. Is it clear? So what about the junction layer? What about the junction layer? The junction layer, it will be, the width of junction layer will be more. What about the depletion layer? The width of depletion layer, the width of depletion layer will be more. If width of depletion layer will be more, what about the resistance? Resistance will be more and current cannot flow. Current cannot flow. So it will act as open circuit. Here it will act as short circuit. Here potential, one point you can write here, depletion, the width of depletion layer decreases in this case, but here the width of depletion layer increases and R become more, current cannot flow. It will act as open circuit. But there is some leakage current flows near the junction due to minority charge carrier. Most important, due to minority charge carrier, leakage current will flow. Leakage current will flow. Again I repeat, most important, due to minority charge carrier, not due to any other potential. Due to minority charge carrier, a small amount of current will flow. That current is called leakage current or reverse current. Understood? So here one important point to remember, if your supply voltage is more than VZ, if your supply voltage is more than VZ, VZ क्या है? VZ is the breakdown voltage. If your supply voltage is more than breakdown voltage, then what will happen? That voltage will help to break the existing bond. So मतलब huge number of minority charge carrier will be created. Are you getting my point? What is the role of VZ? VZ is the maximum voltage, or it is the breakdown voltage. It will help to break the existing covalent bond. Understood? So due to that VZ, we can get more number of minority charge carrier. So that means if supply voltage, if that negative supply voltage is more than VZ, so that means we can get more number of minority charge carrier. So if there will be more number of minority charge carrier, so there will be a sudden flow of reverse current. But that condition is applicable if V is more than VZ. Are you getting my point? If V is more than VZ, that condition you can apply. Then reverse current will flow. Understood? So if I plot the graph, if I draw the characteristics, in x-axis I take voltage, in y-axis I take current. But during forward bias, V positive, I positive, current we can take in milliampere. So here, since your forward knee voltage is very less, barrier potential is very less, so less amount of voltage is required to break. मतलब here less amount of voltage is required to break. ये हो गया knee voltage. Understood? So very small amount of voltage is required to break the junction, then current can easily flow. Then after this one current can flow. ठीक है, ये हो गया VI characteristics of PN junction during forward bias. But during reverse bias क्या होगा? रिवर्स बायस में व्हाट अबाउट द करंट? इनिशियल करंट तो जीरो है ना, current cannot flow. But at a particular voltage, when V is more than Vz, then breakdown starts. So once it will break the entire junction, then reverse current suddenly flow. ये हो गया reverse current, and that current we can take in terms of microampere. Understood? So that is all about the VI characteristics of PN junction. Most important point is this one and this one. So again I conclude the entire thing by comparing biasing two type, forward bias and reverse bias. Forward bias में क्या होता है? Plus is connected to P, minus is connected to N. Reverse bias में क्या होता है? Minus is connected to P, plus is connected to N. But when potential difference is given to that PN junction, that potential difference will develop an electric field which will act against that electric field due to the potential barrier. So since potential barrier is the magnitude of potential barrier is very small, so small amount of voltage is required to break down this junction or eliminate the junction. Then resistance becomes zero and it can conduct a current. Look at the graph. Very small amount of voltage is required to break down the junction. Then current can flow. Right? But during reverse bias situation, minus is connected to P and plus is connected to N. Again, same thing, that potential difference will develop an electric field. That electric field act in the same direction of electric field due to the potential difference. Matlab that electric field will support it. So more and more number of plus and minus charge will accumulate here. So the width of the depletion layer will be increasing. If width will increase, then what about the resistance? Resistance will increase, so it cannot, current cannot flow. So it will act as open circuit. Clear? But at a particular voltage, if I keep on increasing the negative voltage, increasing, for a particular voltage, I will find that voltage is called Zener volt. If that voltage is more than the Zener voltage, it is called breakdown voltage. If the voltage is more than Zener voltage or breakdown voltage, then what will happen? That voltage will help to break all the coexist bond, and more number of minority charge carrier will develop. So near the junction, more and more number of minority charge carrier develop. As I have told, some leakage current was flowing due to the movement of minority charge carrier. If number of minority charge carrier will be more, that leakage current will be more. At a particular point, we'll find and the entire junction will complete breakdown and reverse saturation current will flow. You will get reverse saturation current. Reverse saturation current. I hope you understood. Okay. So with this, I'm ending this lecture. Hope you guys understood what I've explained today. So thank you so much for watching my video. Thank you.